Now we're ready to move to chapter 4, which is talking about work and energy. In this chapter, expect to learn the equations of work and energy and the relation between forces, work and energy, and all the equations connecting all those parameters together. Before we dip into details for work and energy, let's first talk about circular motion. Circular motion is defined as a motion of an object around a fixed center or a fixed axle. You can easily imagine that by looking at the wheel of the bicycle. The wheel is rotating around a center or an axle that we call it axle of rotation, and it is having a certain speed or certain acceleration around that axle, either due to gravity or due to a certain force or due to friction. Probably you experienced that while driving your bike in a rainy day, that your back after a while would be full with water driplets. Those water driplets are caused by the rear tire of your bike. What happens in this case? It is basically related to circular motion. When you drive over a wet surface, the tire is rotating clockwise in this case, so this surface or the tip of the tire will carry water droplets with it, and those water droplets will be launched towards your back. In more details, we have here the center of your tire or of your bike, then you have the radial line, and you have this tip point or the surface of the tire along the tangential line of the tire. The path of the water is expected to be launched on a 90 degrees according or relative to the radial line. Usually there is the center of rotation and there is a distance r, and that's the surface of your tire, and there is a velocity for that exact droplet at that location. That droplet, due to motion, it will be launched with a certain velocity and it will become basically a momentarily projectile that will hit towards your back while driving the bike on a wet surface. More details will be explained as moving forward, mathematical and physical wise. Let's assume you drive your bike on a road that is having a lot of tiny little rocks. You know that by experience that some of these little tiny rocks will stick between the grooves of the tire surface, and those rocks will be launched and hitting all over the place, especially if you are in a pavement road. So the pebble or the little rock will be caught in the wheel of the bike and move from position A to position B as the tire is moving, and the position of the rock moving from A to B along a certain time that we call it delta t, and from the point A to point B the velocity of the rock on the surface of the tire is changing. So the pebble moved from point A to point B, moved through an angle as well relative to the center of rotation, and there is a change of velocity as we discussed. So you have point A, you draw a line from the center to point A and from the center to point B, and there is a time that's been spent until the rock moved from point A to point B called delta t, and there's a distance as well between point A and B called delta d, and there is velocity A and velocity B. If the rock lost contact at this point, he will launch with velocity VA, and if he lost contact at point B, he will launch with a velocity VB. As you know, we can do vector velocity analysis at point B, and that will tell you delta V from the tail of VB to the head of the minus VA. That will give you the resultant velocity of the rock between point A and B. So as delta t decreases, the change between VA and VB will be smaller, and delta V will point toward the center of the circle. Now, it's important to discuss about the velocity and acceleration towards the center. As you have in the tire of the bike example, you have the velocity V at the surface of the tire. You have something called the acceleration toward the center. That is always happening as long as you're having rotation, same as the normal force while you are walking at the surface of Earth. Changing in velocity is the change in direction of the object, not the speed. If the object changes the speed or the velocity, then it has acceleration, and the change in velocity pointing inward toward the center of the circle. And if that's the case, the acceleration must also be in that direction. That's what we call the centripetal acceleration, or the acceleration towards the center, AC. For an object moving with circular motion, it must experience the acceleration toward the center, or centripetal acceleration. If the circular motion is uniform, then the centripetal acceleration is uniform as well. So you can define centripetal acceleration is acceleration acting toward the center of the circle, center seeking acceleration. Centripetal force is a force acting toward the center of a circle, causing an object to move in circular path.